So, uh, so that was JDBC. So we'll start web development now. The next part of our advanced Java web development. So in this, so we'll be first going through Java networking. Fine. First, we'll understand. I mean, the networking part, like different terminology in networking. What is TCP/IP? What is protocol? What is HTTPS? Right? Socket, maybe port number. What is connection oriented? Connectionless. Protocol. Right? We'll see. We'll be watching out those things first on web development, right? And then once this is done, once we are clear with the protocols, right, and different terminology of networking, we'll also see some of the examples under this, like how can we create a socket programming in Java, and socket programming is nothing but a connection oriented program, and what is datagram programming. Datagram is connectionless. What is the difference between connectionless and these things we'll be checking out, and then we'll understand different terminology of HTTP. What is a base of HTTP, whether it is connection or connectionless and all, right? We'll be checking out that. So once we are clear with the Java networking part, then we'll move on with servlets in. So this is where we actually move on with the actual web part, Java web part. So in this servlets part, we'll first understand the two things, which is CGI and ASP, right? And then we'll move on to servlets. We'll just see why do we have servlets and what exactly is guys, can you just mute up yourself? It seems there is some background noise, please. Yeah. So it is we'll first understand these two, and then we'll get back to servlets, right? So which is the actual part of web development thing. We'll understand complete why we have servlets, what exactly are they in servlets and all, right? So this is completely heart of web development in Java, right? So everywhere we'll get
sorry to disturb. I think you forgot the recording.
Yeah, I'm recording it actually.
Okay.
Yeah,
I didn't see it.
Yeah, sure, not a problem. Thank you. Okay, so this you'll be getting this in every part of the development, every part in the sense, even in JSPs. If you have to understand JSPs and even the frameworks, right, you should have good understanding on servlets. So I would recommend you to give more attention to this servlets part, right, because this is a key thing. So any server like Tomcat or WebLogic or anything, JBoss or WebSphere, anything, right? They are mainly designed to provide servlet containers, right? So that is how the complete web work on different servers. Right? The servlet container should be so powerful and so optimizedly developed so that the web application should be more fast enough, right? So that we'll be checking out in our complete servlets, right? And once the servlets is done, then we'll be moving on to JSPs, right? JSPs, which is completely like HTML plus servlet, is nothing but a JSP. You can call it that way. Or servlet is something which is on top of which JSPs are designed, and we'll be checking out the life cycles and everything. Right? So I'm just giving you a top level. So this will be our complete web development part, which we'll be learning across the classes, right? And then once these are done, we'll be checking out some site. I'll be designing some pages, maybe not complete web development, but yes, whenever there is a JSP thing, I'll be developing a simple JSPs like login and how it is moving on from JSP to servlet to JSP, all these things, right? We'll be checking multiple combinations of that. So that will be our complete web development part. So we'll be starting with Java networking. So once these are done, then we'll be moving on to frameworks, right? So that will be our agenda now. So first we'll just start with networking first now. So networking is this is Java networking. The pattern what we are going to learn is same across all the languages, right? there will be no difference, because networking is something where you are actually connecting two different computer devices together in order to share something. That is what is a network, right? The main you know thesis behind this is to connect to two different resources, either I can say, or facilities, and do some sharing and all, right? So the main advantage of this networking is that you can actually share the resources, and you can create something called centralized. You can create a centralized software management. So this is the main theme of management. So right, this is the main theme of something called networking, or any networking, right? Because if you're talking about networking, which means you are placing a piece of code at one machine and you are trying to serve that across the whole world. Or if you are working on intranet, which means you are serving that part of code to the whole team who are working on the same intranet, right? Or across intranets, or across subnets, right? It can be anything, right? But the basic idea is to share your piece of code, which makes which only some service is deployed to the piece of people, right? So that is what is the main thesis of networking. So in order to achieve this networking, right, we have got some terminology which we have now. So we call it as network. We have something called network terminologies. So we'll be checking out few terminologies. So first we have something called the base, which we have to understand is address, IP address. Now what is IP address? So this IP address is something which is we call it as a unique number assigned to a node of a network, right? Unique number of your machine which is assigned to a network actually. It's like hub. You are assigning your IP to your machine. Let me just give you a tutorial there. So in our regular machines, right, if you are having a laptop or a machine or a personal computer, right, so there are two types of IP addresses which you will see always. So we'll be seeing dynamic IP, right, or a static IP, right? Dynamic IP is something, there is a IP which we have in a sense in our regular machines. It can be a personal laptop or personal machine. This dynamic IP is something, whenever you change whenever you restart your machine, right, your IP will change. That is a dynamic IP, right? Now if you want to check your IP, I hope you guys know where to check. There are so many ways to check your IP. If you want to check, maybe you can go to command prompt. You can just say IP config, right? So you can see there are so many network IPs here connected. So there will be one IP which is IPv4 address, right? This will be your IP, sort of. And there are so many. You can see there are some Ethernet IPs, some tunnel IPs which are connected to, which are they will be created by the mode of internet you are connected, right? Based on that, it will be registered with your internet. Now, what is dynamic and what is static, and what is the one which is mostly used for networking will be the question. Now, dynamic is something, as I said, it is something which is created on refresh of your machine. Refresh can be shut down and start, and or it can be restarted. Now, why do we have dynamic IPs? Right? If you are using your machine, right, you don't need an IP, right? Obviously, if you are using your CPU, you don't need IP because you don't have to share anything with the outside world. But why do you have IP is, if you want to connect to internet, right, you should get something, which means you have to get some data from the shared machine. Which means, if you want to get data from shared machine, which means you are about to connect to some server. Which means if you are about to connect to some server, right, which is, let us say this is some server, right? Where let us say there is something in here and you are a client. So this server I'm talking about, let us say internet server. You have taken some internet connection. Now there is a you have taken a cable connection. I'm just giving a very layman example here, right? So here, whenever if you have a cable connection, right, the first thing what it does is how it comes to server is there will be something called routers. You would have heard of something called routers in between, right? Router is something which will make a physical connection between, this is a main point of connection which will be made to the server and to your machine, right? So what router will do is, router will generate a random IP for your machine, right? So let us say if you have started your machine and if you connect to a router cable, right, or if you connect to any Wi-Fi router or any hotspot or anything, right, what happens is in order to make a connection there should be something called IP. IP is like a like door number, right, in a street. So let us say a router is created for multiple machines, let us say, right? So there are four different guys or four different houses are there where there are each computer in each house, which means this router can be connected to multiple machines, right? Now, which means whenever internet serves some internet pages, right? So this should know to which computer I have to send that page. So for that, what happens is this is a router. So for that, obviously, each and every machine will have a unique IP, right? Even if it is a dynamic, it will have a unique IP. So that IP will be registered with the router, right? It will be generating a random IP and it will be registered with your router. And this until you disconnect your internet or until you shut down a machine, right, that IP will be common with your router, right? And it will be connected to a server. Fine. So that's why we have seen sometimes, right, whenever you restart or do machine and just connect to cable, right? I mean, just disconnect for some time, don't shut down and keep it open and connect it again. What happens? Sometimes you will see some issue called your IP conflict happened, right? You would have seen that. What is IP conflict? IP conflict is nothing but, let us say you have disconnected your internet connection, but your machine is open. Let us say your machine have got generated some IP. Now IP will be in something called octets, which is some. Let me just give you an example of 198 dot some 2.0.5 some IP, right? So these IPs have got generated to your machine. Now when you disconnect your machine, maybe some other guy restarted and just he was about to connect to internet. What happened? The random IP, the same IP can be generated to this guy because it was not our IP is not now currently registered with this router. Then after that, if you try to connect again, which means it will give you that yes, there is a IP conflict. Either you have to restart a machine or it will say it will give you some options to do that, right? So that is what is called as IP conflict. IP conflict happens when in a same network. Now if you can see here, all the machines are connected to the same router, which means they are in the same network, right? So this network can be intranet or internet. If it is an intranet, then obviously the routers can be shared and one machine can access another machine. If it is internet, right? Internet is more secure. If it is an internet, then obviously now even if it is internet, now you can see my shared machine in your screen, right? You can see that, which means I have provided some access privileges in order to see my screen from your machine, which means there is an IP created in my machine and there will be one more IP will be created in your machine, which means this router is helping us to gather the information from this IP from my machine, keep it here and share it back to your machine through your internet. Anyways, it won't be going through this, it will be going through router, go back to server, from server get back to the router, because this router is not the same for me and you, because if you are staying at some other place in US, right, which means your routers will be different. But only thing what router do is it will take up the message whatever I'm sending, that is through router, save it in server, or in server whatever what it will find your IP, on which router it is, and it will place in that router. Maybe if this is a router which you are working on, so it will send it to this router, and this router will serve you the screen. That is how it works, right? And that is how this is a very raw kind of communication which I have shown. The internet works in rather better way, right? I'll show you that once you understand this, right? So that is something which is like a IP of your machine, right? And this IP, that is called as a dynamic IP, right? Where every time your machine IP is being changed, right? Every time you restart, or every time whenever it is connected to network, right, your IP may change, right? And obviously, yes, dynamic IP is something where you are not keeping anything common, right? So even if your IP changes, doesn't matter. The changed IP, if you register with router, you will be getting your data. Now let's come back to the server part. So whenever I say server, right, server should have same IP, am I right? Because you will be accessing the server. Now, why I am saying you will be accessing server is, now let us say you have done www.google.com, which means google.com is nothing but a domain name which will be registered with some IP. Now, what is domain name here? We'll understand that. Now, how does it work is in this way. Let me go to the next slide. So how the server, let us say this is Google server, this is server, right? Let us say this is Google server, and the machine name. So every machine will have its own IP, as I said. So pertaining to this IP, they would have connected something called the host name. Let us say the host name of this server is, let us say google.com is my host name, the machine name. Now, it doesn't matter if your machine name is google.com. It doesn't mean that you are actually accessing this host name. No, never. You are not accessing this host name. Now, what is that? How we are getting that? Let us say you are a client here. You are sitting in a client machine here, and you are trying to access google.com. So whenever you type in google.com, right, which means you are not actually accessing your host name of a server. Instead, you will be having in between something called internet hub. You have something called hub, which is called as an internet hub. So now this is a very big system where if you want to go live with your website, let us say you have created a website, and if you want to go live, if you keep that website in your machine, you can't make it live, right? Obviously you can't make it live. What you have to do? You have to buy some data from internet, or we also called as you have to buy something called domain name from internet, right? So there are some internet guys like you would have heard of something called godaddy.com or biggrok.com or networksolutions.com, right? So these guys are someone who provide domain names. Domain names in the sense, what they'll do, it is two types. They'll provide a domain and they themselves provide a server where you can place your data, and that data will be live into internet. Or let us say you have got your own server. Let us say you have a server, and what you'll do, you just say I want a domain name where I want to make my server where I'll keep all the files, right? Which means your IP will be registered with some name. Let us say now this domain name is called as www.google.com. Let us say. Now this google.com, you have made it as a machine name. They may be same or they may not be same, but rather most of the time, not most of the time, all the time, your machine name will be taken as this, right? Now you have taken your google.com. Now what happens, which means what we are doing here, in our internet hub, to some domain name, we are registering the IP. Am I right? Which means every time all the clients, whenever they do some, whenever they browse on to google.com, which means, so where to which they are connecting, they are actually connecting to the hub, but they are not connecting to the direct server. No, never. They are connecting to the hub, and this hub is internally connected to the server, which means you are actually connecting. So this hub will have its own IP base. Now, whenever you say google.com, based on the internet provider, let us say you are actually having an internet provider, right? So they will be having their own hubs. So now you are first connecting to the internet hub. So internally, if you search for google.com, now this google.com is, let us say, it is actually registered with something called 198.5.200.1, let us say, something. So this IP is the server's IP. Now what happens? This domain name will be automatically routed. It will route your request to the server called google.com. Now this server again will respond, and this hub will take care of that response will be routed to you. So that is how your communication does. Now this is a hub now. Here you will, if you have noticed one thing, like IP here. So if I continuously change my IP, right, what happens here? Which means I said in a machine, right, your IP will be changed once you restart the machine. But here in server, if IP changes, what happens to domain name? The connection will be lost, right? You lose the connection because you will always have to register your IP with a domain name. Which means you have to make your IP standard. So that standard IP is called as your static IP. So this is something, static IP, which is making, if you want to make your server live, if you want to make your server live intranet or internet, right, you have to make your IP static. Now, how can I make your IP static? Which means you have to register this with your network guys, right, with your network. So that's why, if you want to make your IP static, it's very costly. It's very costly because you have to buy the IP. You have to buy the IP from network guys in order to make your PC static IP. But yes, if you are making your PC static, then you have to make sure your PC is secure, right? So once you make your IP static, which means anyone else, if anyone knows that this is your IP, you can easily correct the server. That's why there is a concept of firewall. That's why there is a concept of antiviruses, right? So many things in your hub and in your server before accepting a request. That's how it goes. If you're making a server or a machine IP static, then obviously you have to take care many secure things, right? That's why if bigger corporate companies and all, they go for their own servers like oracle.com or amazon.com or google.com, yahoo.com. They will have their own server machines in their premises. But yes, if as an individual, if you want to, you have created a simple website of your own, some blog or some website, right? If you want to go live, you cannot keep your server with your own, right? Yes, I am not saying you cannot, but you have to take care of everything, security measures and all. Instead of that, what you'll be doing is you'll be going to the network guys. So they will have bigger servers. What you'll do, you'll buy some space in their server. Instead of having a separate server and putting up a hard disk of memory 500 GB or placing your Stormcat server or IIS or WebLogic or anything, right? You don't have to bother about that. There are some internet providers where you can go and actually with the creation of domain name, they'll also provide some space in their server. But yes, you will be having access to that server based on the network name you are actually creating. That is, if I'm creating something called www.srinath.com, I don't have to maintain my own server. I can just buy some piece of memory and I can work on my domain. So that's how it works, because their servers will be more secure. They will be maintaining more secure servers because they have to maintain so many websites of so many clients, right? I'm talking about if you are an individual, and yes, it can be that you are an individual. If it is a small firm, if it is a small consultancy, let's say, right? Small consultancy, yes, obviously even they will be going for some internet providers, right? Buy some space and create their own domain name and publish their website. So that is how it goes. That is what is if you are doing that part, which means they are actually registering their own static IP, right? So that is a static IP here. That is all about IP address. So here you can see IP address is so important in order to make your network live, right? And this IP always consists of something called octets. Like it will be of octets from 0 to, I think, 0 to it is 255. So it will be using these octets. Like octets is something where you can see each and every IP part. So it will be separated with 3 dots. There will be 4 sections, like 195 or something called 23 or some 0.1, right? This will be your IP, and each and every number, right, will be in between 0 to 255, right? It won't be beyond that, which is a universal standard. So that is your IP address, right? And now this is something where you have seen something called how internet works here, right? Now let us understand what is a protocol. Now what is a protocol here? We have, see now, if until unless you know what is an IP address, right? Or okay, first let us go to port. Before protocol, let us go to port. Now what is this port? So we have seen so many things that yes, my IP will be registered, will go there, right? And it will go to server and get back and all, right? Now here IP address is like a street. A street, right? So here, let us say, let me take the pointer here. Let us say it's a group of machines I have. In a street, there are so many there are multiple houses there. In each house, there is a machine. Now, they'll be having their own IP. Yes, I can understand that. Which means it's a big, city which you have, in which you have small streets. There are small streets. Now in these small streets there will be so many houses, right? It won't be one. Now here internet is something, the IP is an address of that street. Now once we enter into that street, we should know to which house we have to deliver the letter address. Let us say internet is something like a postman, and whenever we actually say google.com, it has to get a page. That page is something like a letter. It has to deliver it to some door, right? But the door part is called as a port. There will be multiple ports in a machine. It won't be one. As your operating system is capable of creating port, that's why you are able to browse on something. That's why you are able to connect to some network, right? As your operating system is able to create an IP, right? Able to create an IP with support of internet, with support of network, or right, or in order to connect to some network, right? That's why you are able to browse onto the internet, right? That is what is a port. Until unless you have a port, you cannot do any sort of communication, which means with this hub, your IP and port will be registered. That is second thing. But IP is something like a address of a street, and port is something where actually the letter will be delivered. The same thing will be with your server. In server, you won't be actually exposing only IP. No, never. Or if you just give an IP to the domain guy, it won't work. What do you have to say? You have to say yes. In this server, your IP and your port has to be exposed to the outside world. Now, the question is, yes, you can buy an IP. Now, how to fix a port is your question. So, the fixing port will be done through your web server. Now, we'll be learning something called Tomcat. Yes, I forgot to mention that. Yeah, we'll be learning across this. After Java networking, we'll be learning Tomcat first. We'll be learning one web server, which is Tomcat. We'll see how Tomcat works or how this web server works. Right? So that is your. When we learn this, then I'll show you how to fix up a port. It's very important to know this, because IP, anyways, if you have a machine, right, you can make your machine static IP by buying that. But the only thing is you have to fix up your port here. We'll see how to fix up your port when we actually come to a Tomcat part, right? So that is a port. And then you have something called, as I said, protocol. This protocol is something, it's a big word, right? There are so many protocols, right? You have TCP/IP protocol, right? You would have heard of this. So what is TCP/IP? TCP/IP is nothing but, the basic expansion is transfer or transmission control protocol or internet over the IP, which is over the internet protocol. So this TCP/IP is mainly used to make something called connection-based programming. In order to make a connection-based programming, we will be working on TCP. And anyways, a complete internet works on TCP/IP. Right? And you would have heard of HTTP, which is Hypertext Transfer Protocol. So this is a protocol which works on the internet, right? Which works through some protocols like it's a HTTP or SOAP or HTTPS or something, right? And this HTTP completely works on TCP/IP. We'll be writing one program, one socket program, right? Don't worry, and I'll show you how it works, right? And then you have something called UDP. UDP is, as I said, these two are something called as connection-oriented, socket programming or connection-oriented protocols. And UDP is something which is called as I don't know whether you have heard of this, user datagram protocol, right? So this user datagram protocol is something which is connectionless protocol. Now what is connectionless? See here, we understand this, which is, if you make connection between two machines, then yes, I can send a request and I can get a response, or this can send a request and this can get a response, because there is a direct pipeline or something created. Now what is connectionless? Connectionless is something which is like, it should be like this. So what happens here is, in some intranet or internets, let us say there is a server, it contains some port, let us say, right? And in this server, let us say it's a hub or something called router, where there are multiple machines, let us say. Now what happens here is, let us say there is a network pool here where this contains some IP and port, and now also this contains an IP and port. Now in this router, right, let us say this server is something which is from some port, what it is doing is, it is just throwing the messages. It's just keeping the messages in a socket. We'll write one program for datagram, don't worry. So what happens, these messages will be staying at your router part, right? Now what happens, these machines will be listening to some port. Let us say this port. It doesn't know to which machine it is connecting. It is just listening to this router. So whenever it gets a message, it will be grabbed by this machine. And yes, there can be chance that you may miss message. So that is the main theme of your UDP, which is datagram protocol. There is no guarantee that you will be getting message for sure. There is no guarantee that you will get that message in specified time. No, you will not have that, right? And also you may not be having guarantee that whatever message is being sent is the only message, right? Or you can't say whether the message will arrive here. You can't say that how much time it will arrive. It may be missed, right? So that is something which is an datagram. There will be only one side communication. Just it will be throwing up and it will be received. So this is something like broadcast. You have heard of broadcast, let us say. So where it will be done mostly, let us say there are some websites which are getting stock market updates, right? Stock updates. Let us say Thomson Reuters is one router, which is, you have heard of Thomson Reuters, or there are so many data providers in internet, not data providers, the third party guys, which if you register, and sometimes the registration will be free. If you register, what you give, it will pass on some messages. So those messages are like, let us say whatever is going on in market. Let us say Nasdaq is moving on like this. Let us say Apple stock is this much, right? Google stock is this much. So all these things are like stock market information. What they'll do, it will be just giving out them packets. It will just giving out your messages. And what happens here, your intermediate guys, which are router guys, right? It will catch up and they'll publish in their server. So that is what you are actually getting. So that could be sometimes will be done using internal to these servers. That is, if you use some Thomson Reuters server. So these guys will be communicating using UDP, right? UDP. And after getting the message, the server will be publishing to the clients, right? So that is how. But anyway, from server to client, if you are actually using, there should be a direct connection. This can be a HTTP, which is running on your TCP. But yes, this server may be talking to some other server using the UDP protocol, right? So that is how your UDP works, which is connectionless protocol, right? And then you would have heard of something called FTP, a file transfer protocol, right? If you want to upload any data, right? Let us say there is a site where you are actually uploading your resume, right? They may be using something called FTP protocol, secured FTP protocol, right? Where you are actually uploading a resume from one machine, which is your machine, to some other machine, which is a remotely, placed a server, maybe, right? You are actually uploading that. You may use something called FTP, file transfer protocol. And you also have something called SMTP. Even there is a protocol. SMTP is simple mail transfer protocol. You can also write a simple mail protocol by using a Java SMTP. I'll show you that. Right? SMTP is also a protocol. Now, whatever mail client you are using, it can be your Google, it can be your Outlook, it can be Yahoo, or it can be anything, Rediff, or AOL.in, or in.anything, or anything, right? So everyone, if they are providing their mail engine machines, they will be using their own SMTPs, which is simple mail transfer protocol. This knows how to transfer mails in between and how to send it out. Right? They will be having their own SMTP servers. Right? Yeah, Arjuna?
So you mean to say it's an email, right? Email.
Yeah, it's an messaging transfer. Yeah.
So it's a mail or mail? Simple mail.
I'm sorry. It's a mail. It's simple mail transfer. Sorry, thanks. I just yeah, it's a email thing. Okay. It's SMTP is something which is simple mail transfer protocol. Mail. Okay. Which is used for actually communicating different mail things over this protocol. But anyways, this SMTP may work on HTTP, yes, because you are actually converting internally to HTTP or some other protocols. Right? It can happen. Right? Even if you're let us say if you're using your smartphone, right? It can be Android or iPhone. If you're setting up your mail client in your mobile phone, which means again even that uses your SMTP protocol over the network, which means if you are connected to your mobile with a mobile data or Wi-Fi or with some hotspot or with anything, right? Which means that will create a network for you, right? That is creating a network where you're actually receiving the packets. So your servers, like if you're configured a Gmail client, right? Which means Gmail server will have something called push service. Whenever you get an email or whatever you do from your mobile client, right? It will be having its push service to get the data to your mobile, right? So that is why nowadays you would have heard of something called cloud based programs, right? Cloud based programs are something where, as I was talking about the server, right? Let us say you have this server and you have some database. Now let us say this is a mobile where you have installed a mobile client. Now whenever you communicate with the server, now if that request is something where it is actually talking to database, it is actually talking to web service, it is actually talking to some servlet, then if you are getting the response, it will be so slow, right? It can be a bit slow, because mobile client should get like a click, you should get data in no time. But yes, if you are working in a laptop or machine, yes, if there is a delay in responses, you feel that yes, something is going on, but it is not the case with your mobile, which means the communication should be so fast enough, right? That's why all your mail clients and everything has built a cloud on your servers. What is the cloud is all the data part, all the data part will be virtualized and will be keeping in a cache, which means you are actually talking to the cache, and the cache memory is actually updating these things into your databases. This is something which a layer is being created to make the communication faster, right? And the update part will be, which is sync part, will be done in a separate threadings. So that is something how the, but yes, even in that case, even to access the cloud, obviously you have to connect to machine, right? So that is how it works, right? So there are some protocols here, and these protocols will work on something called sockets. Very important thing here. So this is something to create an endpoint connection. The socket is something which is a combination. It can be a combination of IP and port. The combination of this, we call it as a socket, right? So we also call socket as endpoint of communication. Endpoint of communication, right? So if you want to do anything, right, it can be done through socket. Keep in mind, socket is not separate component or something in machine. It is something which is created out of your IP and port, right? So that is a socket. Socket is basically used to something called do communication parts from server or to the client or from client to the server, right? That is a socket. Now you have two different terms here, which is socket and server socket, right? So these are two things, which is socket and server socket. So server socket is used to create a server. Now here I'm not talking about web application, guys. This very simple network I'm showing in between two machines which are connected directly in internet, or sorry, intranet or this web internet. So here I'll be showing something which is where we'll create a socket, right, and then we'll create a server socket, and we'll try to communicate in between socket and a server socket. Now we'll see, because we can create socket, right? Why? Because our machine will have its IP and will have its own port. That's why we will be able to do that. Now here there is one more thing to understand. Let us say if you are trying to access your own IP, right? If you are trying to access your own IP, you have two options. First thing, you can actually you can actually know your IP address, and yes, you can get that IP address and the port. Port you can do anything in the sense, there are some ports which already will be registered. You should never use those ports, right? And what you should use is, you should use some port which is not there. Maybe I'll give you those things. So what exactly I'm talking about, all the sports and all, right? Where you have to create a port. And sometimes in order to access a local IP, right, you can actually give something called local host. Local host is something which is actually referring to the local IP of your machine. That is your local host. And we'll be using this term very often in our web development, because I'll be creating Tomcat, I'll be creating servlets and JSPs, and I'll be deploying all the things in my local machine, right? That's why in order to use the complete IP, I may use localhost, because localhost is something which will always be referring to my local IP. And obviously you have to give this name to your machine. I'll show you this, where actually we'll be giving, right? So that's how we'll be using these things, localhost, port, and different terminology to create our socket program, right? So we'll see different things, how we can use the socket program, right? And how we can actually use server socket. How can we create a server socket and socket, and how we can communicate. I'll show you those things. We'll send a message from server. We'll see how it is received from client. And if you're using this socket, then this is called as a connection-oriented program. Connection-oriented, we call it as protocol. Okay. connection oriented program, because there is something called TCP/IP. This completely works on TCP/IP, and you can see here we are actually using physical IP. If the server will expose its IP port, and if you want to receive something, the socket will be directly connected to this IP and will be getting the message. Right? We'll see how it gets. Right? So that is what is a socket and server socket will be seeing, and then we'll also see something called datagram program. Datagrams. Datagrams is I was just mentioning, which is UDP. UDP is something which mainly works with datagram protocol, and this datagram protocol is something which will not have guarantee that you are actually getting into that or not, right? We also call this as we can also call it as datagram socket. Yes, datagram socket, and we also have something called datagram packet. Right, packet here. Right, this is something which is connectionless. We'll also create one connectionless socket programming, and we'll see how it works. Okay, so yeah, as I said, there is no guarantee in here, right? So this datagram socket is something, right, which is used to send a data or receive data, and packet is something which is, whenever I'm saying packet, it is a message, right, which is a message sent or received in this form by using data socket. That is what. Right? So we'll be checking out these two programs tomorrow, right? And that is what you have the networking part, which are different terminologies. Yes, when we enter into the main part of this, maybe you will be learning more things like HTTP methods, HTTP, right? HTTPS, how you can actually map yourself with HTTP. We'll be learning then and there, right? But yes, these are the something which are basics. We will be checking out. First, we'll be checking out these things, which is our socket programming, how we can write socket, how we can actually get the data from one server to other client. I'll make my machine both the server and client. I'll show you that, right? I'll make my machine. Yeah, you can make that. You can make your own IP a server, your own IP a client. You can do that, right? And then you'll understand. And then what else we have here? We have one thing which is URL, the main thing, right? URL class or URL protocol, and not protocol, URL class maybe, right? You know this URL, right? What is URL? URL is basically we call URL is nothing but your uniform resource location. So this is URL, right? We can also that this is a point of it's a point in a resource. We can also say that in World Wide Web this is a resource point, right? If you want to check out some resource in www, which is World Wide Web, you need something called URL, which is a actual resource location for your web, right? So that is a URL. So this URL contains many components here, right? Let us say, let me just take an example of simple URL. Let us say you have your HTTP, you have this. Let us say you have www dot something, some maybe google.com, let's say, right? .com. Let us say I'm giving some port here from 8080. Yeah. Anyways, you won't see this. I'll explain this part tomorrow. Don't worry. And you have something called some folder. Let us say notes, right? And let us say you have something called maybe index.js. Let us say these are URL. Yeah? This can be your URL, right? So there are so many parts in this. I'll explain you tomorrow. Part and what is this content is very important, right? So we'll see what exactly is these things tomorrow, right? And yes, we'll check out the different parts of this tomorrow. Right? Any doubts in here? So first we'll check out what is the different parts, and then we'll write some socket programming, yes, and then we'll move on to the actual web development in Java from Tomcat side. Fine guys, so let's wind up here. So let me share this video with you guys, right? And yeah, I'll see you tomorrow the same.